All right, hi everyone. So I'm sharing my screen here. Can all of you see that?
Yes.
Okay, great. So, again, this is the first problem we have for today, and the idea here is that I mean the wording itself is a little overloaded. So I'll just quickly go over that. So problem says that you're given a string S and you have to remove the outermost parenthesis of every primitive string in the primitive decomposition. So let's break that down. So here, the important things to note are to understand what is primitive decomposition, and then yeah, that's the big idea here. So if you look at, so here's an example, right? So you have a string S, then if you decompose it into K parts, right? Something like this, each of them is, the primitive decomposition of it. And then the constraint here is that each of these parts, right, P1, P2, they should be a primitive valid parenthesis string. And what I mean by that is we have to kind of break it down, right? So for if you look at valid parenthesis string, this is the example. It can be either something like this, opening, closed brace, or it can be something like this, right? Or a combination of it, like A plus B, right? And the other rule, so that defines just valid parenthesis string. Now, when we add the word primitive to it, that means that there is an additional constraint that whatever string you have, you should not be able to split it any further, right? And it should not be empty. Now, all of this may seem a little confusing, so let's go over a specific example here. So the idea is that you're given an input string like that, and you have to remove the outermost parenthesis of this primitive string in the decomposition. So the first point here is to understand what is the decomposition and then remove the parenthesis. So in this example, let me just put it up on the whiteboard. How do I, let's see.
You will have to stop the sharing and then share the whiteboard.
Right. Okay. So the one example they have is if you have something like, this is tricky to write. And then something like this, right? So if you are given an input string like this, can we actually, okay. Yeah, so here, so let's break it down. So what are the, first of all, primitive decompositions here of this string? Would anyone like to take a shot on that? This is important to understand because if we don't understand the decomposition, a valid primitive decomposition, we won't know which parentheses are we talking about, removing in the question. Does everyone, anyone wants to take a shot at what this is, or if you have questions? So maybe let's go through this example, right? So primitive decomposition, let me put it this way. I'm given this string, and would this be a valid decomposition? So like this. So in this case, I'm saying P1 is this, P2 is this, and P3 is this. Would this be a valid primitive decomposition of this given string here?
Yes.
So when we, so let's look at, so if we, there's one point I missed. So when we say, yes, it is a valid decomposition, that means if I put it back, right, I should be able to get the original string. So
yeah, then, yeah.
Right. So I missed that point, right? Yeah, so then it won't be, right? So that is one critical thing to define primitive decomposition. So given that additional constraint, we understand that this won't be a valid decomposition, right? If I put these three together, that won't be the same as input string. Now, what if I do like this? Like I put this as one set and I put this as another one. Just essentially, I did just, split it up in two parts. So this is easy to see, right? This is like exactly the first part and this is exactly second. So if you just snap them next to each other in the same order, it will be a valid decomposition. Make sense? All right, I'm going with a yes for
Yes.
silence.
Yeah.
So the problem says that given a decomposition like this, where each of them is a valid primitive string, you have to remove the outermost parenthesis. That means the expected output is this, and this, right? Like I took out this one from the first and I took this one from the second, right? So this is what the question requires. Any questions first on the question description?
Could we go over the second example?
Yeah, of course. So let's, so this one I took the first example, but maybe let's take another one. So let's take, oh yeah, we can take this one. So if you look at this one, it's hard to read. All right, so we have a input string like this. Now, what would be the primitive decompositions here? So my thinking is one would be this. And one would be this. And the other one would be, yeah, I think this whole thing, right? Does everyone agree on that? Or
Yes.
let's match with that, what they say here. Yeah, so there are 3 decompositions, right? So now I mean, I couldn't put it as something like this. This wouldn't be right? Because if I snap them together, this is not the same as this. They are nested. Does that make sense? Any questions? Okay. So these are the 3 decompositions. Now, if I take out the parentheses, outer parentheses from each, right? Then you will just, this is hard. Okay, so this is, wait. Okay, so essentially from the first one, I'll take out the outermost parenthesis, then this one and this. Maybe let me share. Can you see this, the actual problem here, or is it not sharing the?
No, it's correct.
Yeah, I see that.
I see that, yeah.
Okay, so here, when you remove the outermost parenthesis, this is what you get, right? You just snap them together and you get the final string. Make sense, or?
Can you go back to the previous screen?
Oh, sure. Whiteboard, you mean? Right?
Where you were typing.
Yeah, the one what you were typing in the text box.
This one here, right?
Mm-hmm.
Yeah.
So what the third, the last line, what it would decompose to?
Right. So actually this is already decomposed. So these three parts here are it's like you can think of it as first is P1, this is P2 and P3. And the last one, you cannot actually further decompose because, for example, if I try to decompose it into anything else, then if I put it together, I won't get the same thing.
Okay, let me see.
So this is like, you can think of it as an atomic, entity. So you cannot decompose it in a way that you can put it back, and it's also not empty, right? So does that answer your question?
Yeah.
Okay. Anything, anyone else? Any other questions? It took me a little while to
Yeah.
grasp that. It's a little tricky to read.
So it seemed to me that you only remove the outermost one, right? Because
Outermost one of each of them, right?
okay.
Yeah, and then you put them together. So the result would be, for example, for the first one, it will be this. And then for the second one, just this, right? Third will be this, and then there will be this nested stuff. No, I made a mistake. Yeah. So this would be like
So you're
first,
saying the last one, this, you cannot decompose it further, right?
right.
Okay.
But does that, like, do you see why that's the case? Because if I try to decompose, right, maybe we can take an example if you have a question. Do you have a decomposition in mind that we want to quickly try?
Yeah, the last one.
Right,
Yeah, so if you further decompose it, you're saying that when you want to put it back,
right,
you cannot put again those two brackets back and it won't be the same as.
right.
Okay.
Yep. So because the only way you can put it back, decompose it further, is you can take this thing out, first one, matching pair, or you can take this one out. But then when you put them back, they are not nested, right, anymore. They are within their own list.
Yeah.
Make sense?
So you are actually just separating it
Yeah.
the way we separate it for the logical way. Yeah. Okay.
Yeah.
Yeah. No
I mean,
problem.
it's more for the definition of the problem that,
Correct.
you decompose it and then take out outermost from each.
Thanks. Yeah. Great.
Yeah. So now, so that's the problem, right? We decompose it, take out the outermost, and that's your final string. You concatenate it. So has anyone tried it, or? If not, maybe we can just, think through, if anyone wants to just think aloud and have ideas about how we'll approach this. So from, like, forgetting about the, coding part or anything, how are we actually manually doing it? If when I gave you this string, right, once we understand what the decompositions are, how are we traversing it? Maybe thinking.
Isn't it simple matching parenthesis problem?
It is
Like you
similar.
just have you have to match the parentheses, and once you find the matching parentheses, just remove that and keep everything what is inside.
That's true. That is the high level right approach. The only caveat here would be that when you say matching parentheses, right, since it's a nested thing, right? So if you, for example,
By matching, I mean, as you said, it's a primitive.
right,
Once you start adding, opening braces,
right,
you have to find a position where the stack will again become empty.
correct, right? So I'm sorry, what's your name? Who is this?
It's Puneet.
Okay, so as Puneet said, right, it's an extension of the parenthesis matching problem, right? So not only you're trying to see the open and matching pair, but you're actually trying to find that complete unit, right, for each dependency. So Puneet, would you like, I mean, so that's the high level idea. I tried two approaches. One was, I found a little more tricky, but there is a simpler one. So how do we want, I have the code written, so maybe I can quickly show that.
Can we go over by hand first?
Yeah, sure, makes sense. So let's do that. So let's maybe I can start with, my approach is very similar to what you said, Puneet. Maybe you tried, let me know if there is another way of implementing it. But the way I did was, so anytime I start traversing the string, right? Anytime I see an open parenthesis, I have a counter variable, right? Like C. Anytime I see an open parenthesis, I increment the counter. And anytime I see a closed, I decrement it, right? That's a typical parenthesis checker problem. Now what happens is, because of this, nested stuff, and you want to look for the whole unit, but the other thing you want to check is when you have a match. So let's walk through the example. So in this case, you start with this index 0, right? Starts with a new item. Okay. So in this case, my C is 0, and then I look at the first element and my C becomes 1, right? Let me know if at any step it's not very clear. And then moving to the next index, again, open parenthesis. So I increment C. Now I come across a closed one and I decrement it, right? And then again, open, increment, and closed one. So I decrement it. And finally, I get another closed one. At this point, my counter is 0. That means I'm using it to track that I have found one decomposition, like, one primitive string of the decomposition, right? Okay. So this is the kind of marker I'm using to marker for a complete matching unit. Make sense so far? And
well, anytime you see if C equals 0, that's the end of one unit.
One unit, and then I need to actually some way copy this thing, right? Because that's my result, like a part of my result, the nested two pairs. So what I do for that is that I track in the beginning, I track the start index, which is 0, right? That's my start of the string. And the moment I hit this mark where I have a complete unit, at that point I say end index is my whatever current string index, right? So in this case, this will be 0, 1, 2, 3, 4, 5. Make sense? And now I just, basically construct a string with this result. So my original string, if it was S, let's say input, then I say create a string which starts from, now if you notice this, the whole idea of this problem is remove the outermost parenthesis, right? We have identified this unit, but I don't want the first one and the last one. So what I'll do is I'll say start index plus 1, and I want to go till the end index, right? Yep. At this point, I will have this in my result.
Yeah, makes sense.
Right? And then I start, I keep on traversing the string, and what will happen again? C will again become 1, right? Because I have the second unit starting. C equals 2, and so on. C equals 1, and then finally again C becomes 0. And this is indeed our second unit, right?
Hmm.
And at this point, actually, there's one more thing I need to do. I need to update my start index. Anytime I construct that sub result, I need to update that to
Yeah.
end index. Yeah. All right. And at this point, again, I'll do the same thing, right? So now my result will be just this. Everyone with me on this,
Yeah.
or any questions?
Yeah. So you keep on appending it to the S, for the second one also. Yeah.
That's true. Yeah.
Okay.
So actually, I should,
sense.
have that somehow.
I know. I just got it. Yeah. Just one.
Yeah. Correct. And I'll just.
So this is the implementation, right?
Right.
Yeah. Makes sense.
Can we mute?
I think you can mute it. Someone with the big name, yeah.
So how much time take? 8 minutes पहुंचने में कितना टाइम लगेगा?
So
पहुंचने में कितना टाइम लगता है?
Maybe can you go ahead and mute the other participants?
Hopefully I didn't mute the person who was actually.
No problem. It's okay.
Okay, cool. We're good. Yeah. So this is the main idea, right? Good so far, everyone?
Yeah, it's clear.
Okay.
It's clear to me at least. Yeah.
Right.
I don't know about others, but yeah, it's clear.
Yeah. If any, yeah.
I have third. Can we handle the third case with the same logic?
Let's try. Okay, so now C would be, let me pull this up. So here, if we look at this, so C till this, oh God, this thing. So C will be 1 for the first, then 2, and then I hit this closing one. And then again, I have 2 open parentheses and 2 closing. So is this right? Yeah. So this thing. And then, oh, are we hitting something? 2, 1. Oh, this should be 3. So, and then this should be 2. And then finally I hit the last closing parenthesis.
I'm confused with the C.
Second last should be 1. Yeah.
And there should be 0 finally. And at that point, I can again trim the, first thing here and first opening brace and the last one, and I'll get the rest of it like this, something like this. So it does work, right? So we get something, just this part here.
So C is equal to 3 because
Right.
of 2 opening parentheses, right?
I'm sorry, I can't. Can you be a little louder?
Equal to 3. So on the third case,
Right.
we use, because of 2 opening parentheses, right?
Adding +2 to the existing count, which was 1. So
Okay.
1 + 2, 3, right?
Got it.
Yeah. Oh, I totally messed up the screen here. Okay, so any questions on this before we move forward with the maybe next question, or we can quickly, complexity analysis should be pretty easy for this, but any questions on this implementation first? All right. Complexity analysis. What do you think for that?
Time complexity is O of n.
And n is the number of characters, right?
Right.
In the string, right?
Yeah. And for the space complexity, I would say it's 0, right?
It's constant, right?
Yeah. Or maybe you can have the output string itself.
Actually, that's true. Yeah,
right?
because we are constructing it, right? So if we use some string builder or whatever, some variable, right? So that would also be proportionate to roughly order of n.
No, normally for the output, we don't, like whatever output, we don't include it in the space complexity.
Yeah,
No, that's true. That's true. But I was accounting for example, here when I'm constructing my, sub result, since it's a string, I can't modify the actual string, right? At least in Java. So I have to create another.
Oh, okay.
You can use string builder, right? And
Correct,
that's
correct. But that's true. And that's what I have used in my implementation in the actual code. But that's where I was thinking we do need a little extra space, right? For creating that string builder and adding that. But is that right? Or
can we try it like if we have each of the decomposition of size under root of n, what will be the time complexity at that time?
Say it again, sorry.
If your each decomposition
Right.
is of size under root n,
Square root of n.
Yeah. So you'll take one loop to iterate over the entire array, and after every under root n, when you're actually matching that, your input.substring will actually traverse and create that sub part, right? So it will be under root of an iteration. Okay.
So where is under root square root n coming in?
I'm just saying, if your each decomposition size is under root of n.
Okay, that's where maybe I'm missing a little bit. So how are we even making that thing that if it is like the case?
So trying to find out the worst case scenario.
Right.
Because you are doing a one iteration of the array from the start to the, or string from the start to end, which is correct.
Correct.
But your input.substring method, right? That is also a linear time complexity. So you have to consider the size of the input string also, your substring that you're calculating. So in worst case, if you have all the decompositions of size under root of n,
okay,
right? So your under root of n decomposition will run number of times. Like this is again going to be under root of n into under root of n.
Right, which will be n, yeah.
Right. So n into n into under root of n, that will be n raised to power 1.5 in the worst case.
I see. To be precise, you're saying. Okay.
Yeah. So what we can do, what you're doing is correct. Just a part, small optimization that we can do in that is, as and when you are going, you start with 1 and then you are trying to figure out 0, you can keep pushing into a string builder. You don't have to revisit that again. Right? So first time you find a 1, don't do anything. After that, till the time you find a 0, keep pushing the characters into your string builder.
Oh, I see what you're saying. Okay. So rather than yeah.
Right.
Okay, interesting thought. Yeah. Okay, thank you. Yeah, that didn't occur.
For our input cases, it will not matter that much, but yeah.
Yeah, but yeah. Thank you. So are we good with this question? Let's see how we are. Oh, it's already 9 o'clock.
Yeah, I think so. We can move to the
next one, right?
Yeah.
So let's. Okay, so let's look at the second problem. Everybody can see my screen with the question, right?
Yes.
Okay, so let me simplify this thing here rather than reading the description here. So what you're given is you have n piles, right? And each pile has certain number of bananas. And the high level goal is you want to finish eating all the bananas in a given amount of time. Here it's called H hours, right? But there are certain constraints to it. First is you want to have a consistent speed. for eating. You want to finish, let's say, eat 8 K bananas per hour, right? And then the other rule is that when you're picking a pile, if you decide a number for K, let's say you want to eat 2 bananas per hour, and if you pick a pile and it has only 1 banana, then that's all that you can do in that hour. You cannot finish 1 banana and then pick another one from another pile during that hour, right? And the other, and so given these two constraints, now your actual final goal is that you also want to, you don't want to rush. So you want to find the minimum value for K, which is your speed, like how many bananas per hour. And so that you can finish all the bananas in H hours, right? So let's again take this example. Sharing, okay. Is it, so can I undo? How do, oh, never mind. Okay, so let's look at this. So here's an example, right? There are 4 piles and you want to finish eating all these bananas in 8 hours, right? And you have to find value for K, which is number of bananas per hour. That what speed do you want to maintain so that you can finish eating all of them in 8 hours? So just since we're discussing an example, so if we say that our solution is K equals 4, and this has to be minimum, right? If you try to go to 3 bananas per hour, you won't be able to finish it in 8 hours. That's the point. So if we take K4, what you can do is from first pile, you finish in, you can finish in first hour, right? So let's keep an count of hours. So you can finish first pile in first hour. And then the second one, you can only eat 4 at a time. So for second one, you need 2 hours. For third one, you need again 2 hours. And for the fourth one, you need 3 hours, right? So this is what? Exactly 8 hours. Make sense? All
Yes.
Right. So let's, so as an example, if we say K equals 8, right? In that case, you will see that you can finish it in much quicker than 8 hours. So would that be a valid solution? Like let's quickly go over this. So K equals 8. So pile 1, you can finish in first hour. Pile 2, you can finish again, just take 1 hour. 3, also 1, and P4, 2 hours. So this will take total of 6 hours, right? So why is this not a valid solution?
Because we want the minimum K.
Yes, so because you still have 2 hours left, right? But you are, trying to increase your speed, which is not what you want. You want to, like you said, you want to actually minimize this. So, and you can try that if we say K equals 3, there is no way you can finish it in 8 hours. So minimum value would be 4. Make sense?
Yes.
Okay.
Yes.
So let's, anyone, ideas if you have tried it?
By looking at, at the example you given,
Yeah.
I think that we can do like the binary search.
Okay.
So let's see, initially, let's say we just pick K equal 3 and we see that invalid.
Okay,
and
so
we're gonna,
and so when we take K equals 3 and we say that we can't finish it, then what do I do next?
let's say the low will be 3 and the high will be 11, because
Yeah.
what I see the max value
Right,
of the
right.
array.
Yep. Right. That's true.
Yeah.
So how do you, so before even going further, yeah, you have the right idea, right? So you're picking 3, that's the minimum. Actually, I mean, ideally you can even have, you can just eat 1 banana. You don't have to have the whole pile, right?
Right.
If I give you a really large number here, you
Yeah.
can just be fine having 1 banana per hour, right?
Right.
So you don't need to necessarily start with 3 because our goal is minimizing it, right? But the max we can have is definitely whatever is the max in the pile, right? You cannot, if you, like the constraint said, if you finish 1 pile in an hour, even if your, let's say max was 13, you finish this pile, you cannot go to any other pile during that hour. So during a certain hour, your max has to be capped at whatever is the max number of bananas amongst all the piles, right?
But in
So,
this case, if the H would have been very large,
right.
so will that
That would still not impact max because if H was, let's say, 20 hours, the constraint that we have that you cannot move to another pile if you finish 1 pile in an hour, that will be kind of a wasted time, right? Let's say you take max as 20, but now you only can have 11
okay,
bananas in one
got
shot,
it.
right? So yeah, so I'm not sure who was explaining the idea. I just, paused to explain this concept there. But do you want to continue on that?
Oh yeah, I could, like we pick the middle one, and we try and see if it greater than greater than or equal to 8, then we
What is greater than equal to 8?
hour. I mean, yeah.
Right. The time it takes, right?
Yeah,
That's true.
hour. Yes.
Yeah, correct. So yeah, thank you. So here's the thing, right? You have these possible options, and like you suggested, so we can start with 1. Or ideally, linear search, we can start with 1, but that's not, we have a better way to do that, right? So we can try binary search, and we can say, let me try with 6. If I eat 6 bananas per hour, where do I stand? So if I can finish eating all the bananas in less than 8 hours, then I know I can do better, right? I can go slower, right? So then I'll move my search to leftmost part. But if I see that at this speed, I cannot finish, right? Then I have to increase my speed, and then I move to the right part. So yeah, that's the high level idea. Um, does that make sense to everyone?
Question, how it is related to binary then? It is just the array and just the moving the pointer, right?
No. So we are splitting it. We are not doing iterative, right? We are splitting. So this is an array. So you're not going like trying 1, 2, 3, 4. You're actually splitting in half, right? You're trying 6 first.
Yeah, I can take the middle. This is like a contiguous array, right?
Correct.
So I'm just getting the middle element. So why I have to go to
No.
binary search?
So the idea is when you take the middle one, after that, let's say if this is not the right value, then you're further splitting this into half. So you're going to 4, which is what binary search does, right?
Yeah. Oh, got it. Okay. When we said like when 6 is not matching, it's less than 8 hours, then we will just move the pointer to the 5. I thought like that is.
Yeah. No. Yeah. So maybe I wasn't very clear. So yeah, so you'll basically do a binary search over the left section, otherwise right one, right? So here the 2 critical points was, first was to identify that you can look at this problem from a binary search perspective. So to identify K, you can do a binary search. And for each value of K, what you can do is you have to write some logic which tells you that whether you can finish eating all bananas in, whatever, you have to determine the number of hours. So you can say something like can finish eating all. So, and I can pass, so essentially this function, I'll pass some parameters, but essentially this function should return Boolean, and it should say, it should tell me, let's say if I have hours, a variable hours, to say that number of hours, time it took to finish, using k as the speed, and then h is my given time, right? Now the logic, what you're returning is return, yeah, I mean, depending on how we write it, but we can say if I took less time, then I know that I can do better. I can further reduce my speed. A search in left section. I'm writing pseudocode because just for clarity, but I hope if any questions, please stop me.
No, I think it makes sense.
Okay. Yeah. So let's look at else right section. Yeah. So let's look at the complexity here. So what do you think would be the complexity for this problem? Time complexity. So let's define some variables, right? You have I piles, and you have, yeah, you have like k is the same thing, like number of bananas. Any thoughts around that?
So actually for the binary search, it would be something like a log of n, right? But actually when you try to calculate the number of files which is been eaten
Right.
up, so you will have to do it, add another variable to that, right? That is what I was thinking.
Exactly.
Yeah.
So yeah, that's true. So this is, you're right, this is log k, and then number of files we have essentially is like I piles, right? So that will be like I times log k, I guess.
Okay.
Actually not even that. So can I say even instead of log k, oops, what did I do? This is new to me. Fun stuff. So what the way I was, so maybe, do you want to write an expression? So is this something I'm doing wrong here? Like does it override this? I want to get back to this actual text I had. Always overrides. Anyways, so does anyone want to come up with an expression just for discussion, right? Like you had somebody had an idea here.
So yeah, we said like log of.
So for binary search, we know we have log complexity, right? And then for traversing through the piles, we need some additional, time. Let's quickly talk about binary search. So what would be the length like of the given array that you are using for binary search? So binary search in general is logarithmic of number of elements, right? So what would be the number of elements in this case?
So is the number of piles, right?
No, in this case, number of elements were 11, right?
Okay, so the min and max you're saying.
Right,
Okay,
so it would be log of...
so the height of piles.
Correct.
The max height of piles.
Yeah, max of... I'm sorry for this confusing thing, but
No,
this
okay.
is...
Yeah, that's fine.
Yeah, so this is log of max count of piles. Something like this, right? So, and then the other logic where we are actually for each value, we are trying to find whether it works or not. We are essentially going over that simple logic, right? Trying all the piles, calculating hours. So I think that would be just order of number of piles, like order of I.
Okay.
And this would be the overall complexity will be this times.
So
the
it would be
combination of two.
O piles multiplied by log of max count of piles, right?
Right. Yeah.
Can we try simulating this can finish eating all function
Yeah, sure.
and try to see if we can do a O of n or we need to change something?
Sure. Let's see. Hopefully I can write better here. So
You can take the second example from the question only and just assume any number and then try to simulate it.
Second example. Oh, from the question. Okay.
Yeah, you can take the second example and try a value 29.
Sure. So like this one here. Okay. So can I clear this up quickly? Good, right?
Yes.
Okay. So this is the example and we want, so this is what's given to us, right? So now we are saying we'll have the input something like going all the way to 30, right? This is what we have to try for binary search.
The binary search part is okay. I'm trying to find the bounds for the function where we are doing.
Right.
Can I eat all, right?
Yeah,
so let's assume you have a value of 29 to check whether you can eat it for all or not.
Okay, makes sense. So can eat all. And let's say you're trying here, you have your piles array and you have a value, right? You have your value of h and test k, right? So do we want to do a walkthrough or like quickly, or how is it you want to?
I'm just trying to see, let's simulate it and let's see if we really need O of n or fill it for.
Okay. So the logic I had was that I'll write it in pseudocode, kind of, that will help anyways in complexity. So I'm saying for each pile I, let's say my current count of bananas is whatever that pile is. And then I'm saying until pile is empty, not empty. Go until pile is not empty, and you will increment your hours, and you say you update your current amount to minus, you can eat k here, which will be 29, for example. And yeah, right. And then you just, outside this for loop, you will say if hours minus h.
So the question is here, which one will you choose to eat first?
I think I'm just going by, just the simple order. I'm not trying to sort or anything. Since I have to eat all bananas anyway, right? So would that matter if I, organize it any other way?
Let's try to see it.
Yeah, I did think of that point, like if, organizing it any better, but this is where I was coming to. My thought was that it won't have an impact because we anyways have to exhaust all the piles. But yeah, I think that's where you were thinking if we can reduce it to log n or something, right? Instead of order of n.
No, not reducing. I was just trying to see if we do really require to choose the one which is having the maximum number of elements at that time or maximum number of bananas at that time to consume that first and then look at the other ones? Will it impact if we actually look at the ones which is having the maximum pile of bananas?
Yeah, more like a greedy approach you are thinking, right?
Right.
Sort of. We can, my initial thought was it shouldn't matter, but now that you're saying maybe it's good to at least come up with the convincing thing that it won't really impact. So maybe we can take it as an, action item and think through and update on the, the channel. I don't know. I'm just trying to keep track of the time. Yeah. Does that make sense? Or if anybody has any thoughts around that right away, feel free to jump in. So his point is that if we are trying to, so one thing there is, we are saying when we say 29, that's just the speed, right, at which I can finish eating that. So we can take quickly an example, right? If I try the same way, so then the first pile will be finished in 1 hour or in 2 hours. Second will be in 1, 3. So rest all will be in 1 hour. Right. So now the point was, maybe if we can reorganize the, the piles, right? If I can go to another pile rather than starting from the first one. So this took like 4, 5, 6 hours, right? What would be another better way of organizing? Maybe 30. I mean, in this case, it won't really help because all of them are less than 29. Maybe we can, do you want to suggest quick?
Let's have 20 updated to 29. The last 20 updated to 20.
Oh, 29, like this one, 29. So in this case, this one took 6 hours. So if we reorganize our list as this, right? Is
Actually,
that
it will not affect. It will not affect.
It will not impact.
We'll have to bring up some sort of file structure where
I
it
think
may
more than
affect.
the way
We can take a look. Yeah, we can look
Yeah.
at the problem, try to create it, and if it's required. Because what I was thinking was, in terms of if it's not required, we can actually use a priority queue. And every time we know whatever we have to reduce, like 29, we take the max from the piles, max heap, reduce the element, and whatever is the remaining, just put it back there.
But how would that help? How would that help? Like if I put,
that'll help you to always take up the piles of elements which is having the maximum remaining banana. Just try to get rid of the maximum pile for now.
No, that is true. I agree with that. But since I'm thinking around that constraint that even if whether you pick a pile which has, because you're only working at a pile at a time, you cannot merge piles or anything, right, to optimize it. Since you only can pick one pile and whatever is remaining there, which is defined by more like that pile count minus this test k variable, right? Whatever that number is, that will stay the same whether you put that pile in the first position or third position.
Right. Yeah, you're right.
Makes sense?
Yeah, it won't need, in this case, will not.
Yeah, but like if, as I'm thinking about your point, if the question was a little tweaked, right, that you can merge piles for the remaining amount to optimize it, I think that's where maybe your idea would be, would help, because now you can optimize like which two piles to merge and how to create that right number.
Makes sense.
Yeah.
Makes sense, yeah.
All right. Any questions on that, on this one? Okay, so so I have a hard stop at 9:30, but I can quickly go over the problem description for third one. And Roger, would you be able to take that up, third one?
Yeah, sure. Actually, it's just 3 minutes, so I think it's better, like, you go for your meeting.
Okay.
Yeah.
Okay. Yes, I'm sorry. I just had a hard stop there.
Yeah, no problem. Let
Okay.
you take a look.
Thank you. Yeah.
So thank you.
Yeah. Thanks. Bye.
Thanks.
So I'll stop sharing, or how is it?
Yeah, you can stop and somehow make me host if it's possible.
Yes. And I think I
Okay,
should.
great.
Can you record also? Can you? Should I? Yeah. Okay.
Yeah, it's already recording, so I think
Okay.
should be
Perfect.
okay.
Thank you. Thanks, everyone.
Yeah, thanks.
Thank you.
Thank you, DP. Yeah.
Yep.
All right, guys. So this is one of those moments again where I have no idea, and let's have fun together. We'll see. Can you see my screen? The problems or not yet?
No, it's
Okay.
at least I'm not able to see.
Okay, so let me try to do that. Stop screen. Can you see the problem now?
Yes.
Okay. So I barely looked at this problem just now, so we'll go through it. If you guys have already worked on it, then help me to get to the solution. You have a log in front of you with 4 circular wheels. Each wheel has 10 slots, 0, 1, 2, up to 9. The wheels can rotate freely and wrap around. 9 to 0, 0 to 9. Okay, that means you can continue to rotate it. The log initially starts at 0, 0, 0. Okay. You are given a list of dead ends, meaning if the log displays any of these codes, the wheels of the log will stop turning and you will be unable to open it. I see. So basically when you are rotating, you should avoid those. Or if you reach there, like, that path is basically not going to lead you to the solution. So given a target representing the value of the wheel that will unlock the lock, return the minimum total number of turns required to open the lock, or -1 if it is impossible. Okay. So we have been given a starting point, like which is 0, 0, 0, 0. There are some rules based on which this will change, like, our starting position, and we have a target where we want to reach. That piece I understand. And there are rules that which value is invalid, and that is also given in this dead end. Okay, and they are asking what is the minimum total number of turns required to open the lock. All right, I think I understand the problems and idea also I have. Okay, range is 1 to 500. Target will not be in the listed ends. All right, so let's go through this in a whiteboard. So you are given initial state 0, 0, 0, 0. There are some, like, let's call it invalid states or blacklisted state, something like that. So you have a set here which has all these blacklisted states that is already given to us, and we have to reach to some different destination. Let's call it, I don't remember some value, but suppose 0, 5, 2, 3. And how each of these things can change, like I can rotate this 0, like first 0 in an, like, clockwise direction to get to 1, or anti-clockwise to get to 9. Does that make sense so far?
Yeah.
So you can do that thing on each of these, like, locks, like the wheels basically. Now the password is, for example, 4-digit password. You started with 0, 0, 0, 0, and you have to reach to this place, like, using minimum number of steps. So you guys already get some ideas what you are going to do.
So it is said like at every digit, you can only move one step, either ahead or back, right?
That's right.
Okay. And then you have to keep on going down or any path till you reach this value.
Right. You want to reach to this value.
And that has to be a minimum number of steps.
That has to be minimum number of steps, right?
Mm-hmm. So something like a graph problem, something travels. I just wild guess.
Yeah, like it came to your mind because you said minimum number of steps, right?
Yes, yes.
That is one good thing to think about. And all these steps are what, like basically in one step, what can I do? Think about it. If I was at 0 0 0 0, if I just can take one step, I can go to, for example, 9 here. I can make it 9, right?
Mm-hmm.
This guy.
Yeah.
I can make this 0 to again 9, again 9, again 9. So I know that I can reach to 9999 in just one step, right? I could have also reached to, for example, another state like 9, 1, 9, 9 in one step, right? Because now I chose that this guy should go to 1, not 9. But that is still my one step, right?
Yeah, but actually, I thought like every time you can only change one digit at a time. So one step will be just 9,000 or whatever it is. And the
Oh,
second will be 9,900 and the third will be 9,990, something like that.
okay, let me check that problem then. That's what I understood. So the description says that actually there are some examples also.
Yeah, if you look at the example, it says like that, because.
Yeah, I think you are right. I was wrong. So, okay, let me clear that part. Let me clear that. So, okay, let's just talk about one step.
Mm-hmm.
So I can reach 9000, right? Or I could reach 100 in one step. In one step, I can also just reach 0100 or 0010 or 0001, right?
Right.
I can just choose which one I want to change. But the important thing is all these steps are just all these states of the lock is one step away from where I was, right?
Yes. Yeah.
So basically now you have these many things at your level 1. So many of these, right?
Mm-hmm.
Similarly, when you will go to the next step, you can continue going in the same way, right? Same fashion. Plus, you have this thing also to worry about now. That if you reach to something like, suppose this set had 0, 1, 0, 0 as like blacklisted state. Then this path, like when I reached here, should not lead me to anywhere. So I should just remove it from my possible answer, path to answer.
Okay.
So does that make sense as you were talking or someone was talking?
Yeah, once you find the target string, that could be the shortest path in your search. So we can use the BFS to do the search level by level.
Mm-hmm.
At each level, we create the set, the possible set.
Yep.
Yeah, and put them into the queue.
So you were saying, Roger, like the set what, like 0, 1, 0, 0, if you hit on that dead end,
Yeah.
You are just going to ignore that whole path, whatever you constructed till now, right?
Yeah.
Okay. Okay.
So this set is dead end. I was calling it blacklist. Yeah, but you're right. That's called dead end in the problem.
Yeah. Yeah. Same. Right.
Yeah.
So just ignore that and then keep on doing for the others.
Yeah, because that can still lead you to your target solution, and somewhere maybe like I don't know how I reached, maybe as soon as I reached, for example, this was my target 0523. I have found the shortest path because BFS guarantees you the shortest path,
Oh, okay. Mm-hmm.
right?
Mm-hmm.
So this is a straightforward BFS problem, and recognizing that okay, all these rules are basically nothing but a way to lead to different states are the edges where I can reach. That those were those rules, and that's it. After that, given the bound, I think straightforward BFS may work, but I haven't written code. So if somebody has written code, we can talk about it, but there is one optimization we can also do a little bit. Has anyone written the code for this problem recently, yesterday, or maybe a couple of weeks back? Or any problem with the ideas also? We can talk about ideas.
You said some optimization can
Yeah.
be.
Yeah.
Yeah.
We can talk about.
I just implement the code. I
Okay.
never thought of the optimization.
Yeah, no problem. So if the basic idea is clear, then we can talk about small optimizations. Sometimes those optimizations can squeeze in some like if you are getting a time limit exception, then maybe that will help you a little bit. But other than that, time complexity wise, at least it will be same. Only the constant factor may change. So if things are clear with going like this, and we reach this state using normal BFS, then I can talk about the small optimization. Okay, so I think it's pretty clear. Everybody knows about this. So let me erase this thing. So the small optimization is, and you can do that in many problems, not just this, is meet in the middle. That's what it is called. Meet in the middle. Let me try to pictorially depict this because that's how I think. So you are here, this is your source, and your target will be somewhere, you're growing like this, right? So, okay, suppose your target was here somewhere. So one idea is when you will reach to this level, you will actually get the solution. So you have to go through everything in this area, what this triangle is representing. Does that make sense?
Yes.
Okay, if this is clear, then what we are saying that, hey, let's do traversal from both the ends. So you start traversing like this, I start traversing like this, right? So what will happen, we'll reach somewhere in this area. We will meet somewhere in this area. So we totally reduce this, and this is totally of no use. So our search space has reduced because source moves one step and then target also moves one step. Then source again moves one step and target moves one step. So they will meet in this area for sure somewhere. So what we reduced this part totally. You are not searching or enqueuing these things. Does that make sense or not, guys?
Yeah,
It's very interesting, yeah. but the only thing is, like, if you hit on any of those blacklisted ones, so will that have an impact on this?
No, see, we will just drop those guys. Same thing. We can drop those guys. It's not a problem. Because suppose there was a blacklisted one here. I will say, okay, don't enqueue it. Means this, that will not be part of my, like, next set of it. So it's just a simple pictorial representation for the, but you can see like how much we have already, like, reduced the things.
But how to choose the bottom point?
You are given that, right? So your source was 0, 0, 0, 0. And in my example, I was taking 0, 5, 2, 3 as target. But in the problem, you have target also.
That means choose the target as another point of this BFS.
Yeah. So you have to check, okay, where can I come from? Like 0, 5, 2, 3 can also only come from 2 rotations. Like I can only change this once, right? It can come from 9 or it can come from 1 maybe. Similar to that, right?
So the steps should be summed up from the S point and the target point.
Yeah. So you are walking. That's why it is called meet in the middle.
Yeah.
Because both are now moving.
Yeah. Is it called by BFS? I saw it in the discuss in LeetCode, but I don't know what's the meaning of by BFS.
Yeah, if they are calling bidirectional BFS, then that should be the same concept.
Oh, yeah, cool.
Yep. So that's it for this problem. Now, anything else?
So like when you say optimization, in the sense, the time optimization is almost half or maybe more than that? I just guess.
So time, so you can put some number like, and then you can see how much you go. Like for the worst case, you will be handle everything. So from, for example, you can put some value like this, 1 to 2, 2 to 4. You're going like this.
Okay.
And yeah, you can continue to grow like this, but then you start going like this, put this value. I think it could be 4 times at least, in my opinion.
Okay, yeah.
The constant factor, in my opinion. But yeah, put that value and see like what you get.
Okay, yeah. That's interesting.
So in this context, we are saying we will get from the output state and we will generate other possible states which are reachable from the end or destination state that we want to reach.
So what the question is, let me try to understand, is this, can we move from this target to, like, can we move from this state, if this is my target, to the above states? Are you asking that if it is possible?
I am asking about the optimization you said. So you are trying to say you will generate the states that are reachable from the destination state, and you will from the 0, 0, 0, you will if you encounter any of this, you will stop at that. That is what you are trying to say.
So I'm saying 2 things. Like in first step, that's why I asked, like, if the first step is clear, from 0, 0, we know how many states I can go if I'm looking for the target, right?
Okay.
That were like, a couple of steps we discussed here in the beginning.
Yeah.
Same thing, the next time, like now, target starts to search for the source. And for him also the same rules apply. Like he can also figure out that from which state I am achievable, basically.
Yeah.
Right? If I am given like, 0, 0, 2, 0, I can, based on the given rule, I can totally say, where can I generate this 2 value in one step? When I'm just talking about one step, we can tell that, right? Because you can only change these 4 values. And there are two ways to change all these two values, because we are doing clockwise change or anti-clockwise change. So for all these, you can, make some states which will lead you to this state, right? Is that clear?
Yeah, that's what I was asking. So you are generating which states are actually reachable to the destination state, and you are trying to reach from the start to these states, right?
So the thing is, anywhere, like, some level, I'm just generating where can I reach from this. So now I'm at here, right? Here I was. Eventually, anywhere if we meet, like any state at some level meets, then that just gives me, okay, actually there was a path from here, like this, like this, like this. So I have built a path to meet, right?
Okay. No. I understood in the theoretical concept, but how were you actually, I mean, in the code perspective, how were you implementing the meat in the middle part?
Yeah, so conceptually, what will you do? You may have another queue for it. That's like implementation for this. You can have this, or if somebody was just talking about, somebody said bidirectional BFS, right? You can look at that. I am pretty sure it will be on lead code, right? So
The simplest thing which I can say is, when you're putting elements into a queue, put that into a set also. And you can check for the other parts, like if you're moving from the top to bottom, the state that you're getting, just check whether it's in the opposite ends set already. That means you have already met that. You are meeting in the middle. You can just count the number of steps it has taken from the implementation point of view if you want to look at that way.
yep. Actually, I just checked. There is one. Go ahead and take a look. I haven't looked into it, but there are a lot of problems where you apply this thing. So conceptually, it is that, and I think lead code discuss has this, I guess, similar thing. So look at this approach. They are calling it. They are not calling it meet in the middle, but they are calling regular two-end solution. So I think you should get the idea how to implement it. Other than that, any questions, guys? No?
No, yeah, it was a great, a different approach here. Yeah, I like that. We're trying it, I would say. Yeah.
Yeah. Luckily, somebody said so. It is also on discuss. So go ahead and look at it.
Sure.
And actually, somebody had asked similar questions on our channel. We were talking about all sort of DP on trees and other approaches, and then this had come to my mind as an optimization for that problem also, because the bond was very close to breaching the TLE limit. I don't know the exact what happened with that problem. Did anybody try to solve it? But that is when I also thought maybe this would have worked there to squeeze in your within time limit, because for some of the problems, especially for interviewing problems, BFS should be good enough, and you don't need to go through all those like uh, competitive programming algorithms in general. It's good, it's helpful. The people who do that, it's good for them, but people who are not doing them, if they come up with BFS or like two-way BFS, I think that is good enough. Yeah, so we can you know we can just do this in some other session in detail if you want. But other than that, I think we have run out of time. Like it's 9:52 here. So if there are no questions, we'll drop for today.
Okay. Thank you. Thank you, Roger.
Thank
Yeah.
you, Roger.
Yeah, thanks guys.
Yeah.
Thank you.
Yeah, thank you. Take care.
Bye.